Hi everyone. I hope you all are finding it easy to complete these lessons. Well, with some difficulty, of course. I don't want to make it too easy, but I hope you are able to complete these lessons and easily submit them through Google Classroom. So the reason why I'm making this video is to help you out with this essay question, which is part of the end of plate tectonics assignment. Really, the only thing you have to do is answer this question below about what would the Earth look like if the plates were to completely stop moving, which scientists estimate will happen. So this is the last lesson of the week. So once you finish this one, you are completely done. If this was the last one that you completed, the order doesn't necessarily matter, but I just decided to kind of put this one at the end. Okay, so to help you out to answer the essay question, I want to go over a couple things. So at this point in our learning, we know that the Earth's crust is divided up into plates, and these plates are moving. I'm going to scroll down to show you an image of the plates and the directions in which they move. Now this picture, this image isn't included in the file. You can look on Google Images if you want to find this exact picture, but I'm going to use it as a reference in this video. It will be much easier for me to point out some things. So at this point, we know we have all these different plates. They're made of the lithosphere. They are constantly moving, with the exception of our transform plate boundary here. This kind of slips, so to speak. Pressure builds up, and then we will get a slip, thus producing earthquakes. So remember, all plate boundaries are faults, but not all faults are plate boundaries. So we have a transform plate boundary sliding past each other. We have a divergent plate boundary moving away from each other. I don't know if anyone remembers what feature we have at divergent plate boundaries. This will be on your test next week, so I will be posting a test on Google Forms next week. So take a minute, see if you can remember what geological feature we have in the middle of oceans on a divergent plate boundary. So hopefully you could recall that we have a mid-ocean ridge. Essentially, it is an underwater chain of volcanoes where molten rock, which is liquid rock, it travels towards the surface. It will come out of these openings, cool, form igneous rock, and push the plates apart. Remember, we didn't know that these ridges existed until we had the discovery of sonar, which happened during World War II. So we didn't know this occurred. Remember Wegener, the one who came up with this idea that continents were once together, he didn't have this information. He couldn't explain how they move. So this is one mechanism of how they move. Let's see. So I am looking for a convergent plate boundary. All right, so here we have a convergent plate boundary, two plates going towards each other. And if they are of equal densities, we get a lot of uplift and mountain building here. One thing I want to point out, if we have a divergent plate boundary that is on land instead of in the ocean, we would get a rift valley. Remember we talked about the East African Rift Zone, and part of Africa will be separated from the mainland here. So that's our other type of divergent plate boundary. But we can have two types of convergent plate boundaries, continent to continent, or we can have continental to oceanic. And in that case, when we have continental plate, low density, meeting a high density oceanic plate, we would have a subduction zone. Okay, so, oh yes. So here's our subduction zone. So we have trenches, volcanoes, earthquakes. This is where crust is destroyed. It gets pushed in the earth, and it has the potential, whatever rock that was, to become metamorphic rock with heat and pressure, or if it melts, it will form igneous rock. But there's our subduction zone. That's what I was looking for earlier. So we know that the plates are always moving. because of the heat generated in the core from radioactive elements, and convection currents bring it up, drives these plates, causes plate motion. Now, we talked about the last time I saw you actually, which was almost 3 weeks ago, which is unbelievable. Part of your labs, we did that convection lab. You were supposed to research where this heat in the Earth comes from. And obviously, when the plates move, they create friction, which causes heat. But we have elements like uranium in Earth's core that are radioactive, meaning they will decay and actually turn into different elements. They break down, they are unstable, and when they do that, they release heat. But there's only a certain amount of uranium atoms. At some point, all of that uranium will decay. Now, scientists give different estimates, but one estimate I found was that, if I want to scroll up a little bit, in 4.5 billion years, they think there won't be enough heat for convection to occur to drive plate motion. So, I want us to think about what that means for Earth's landscape when that happens. So, in 1.45 billion years, the plates will come to a halt. Now, I want you to kind of fast forward a couple million years in the future. We will still have the water cycle occurring. We will still have weather. So we have water that evaporates, collects in the clouds, falls down to the surface as rain, and that cycle will continue. So we still have natural elements like that, but the plates are not moving. So to answer this essay question correctly and thoroughly, I want you to think about, and we talked about some of this already in this video, what are some geological features that we see at each type of plate boundary? What are some things that happen because the plates are moving? Now, I don't know, let's say 2 billion years in the future, the plates have been static or stationary for quite some time now. What will the Earth's surface look like? Knowing this fact and knowing we still have weather. What will we see? What will we not see? Think back to the unit, all the geological features we talked about. Take a look at each boundary, see if you can recall. I want you to be as thorough as you can when explaining this. So I'm going to stop here. Hopefully that helped you a little bit. And please remember to check your email for emails from other teachers, although I won't be emailing people frequently. Look on Google Classroom under the Stream tab. That's where my announcements will be. So please look there, and I will soon be posting a lesson or two for next week that you can do early if you would like, but these lessons for the week will be due Sunday night. I'm going to stick to that deadline instead of Friday, what it normally was. So look for another video posted. I'm going to review everything from the week. Okay, so this video is just to help you answer your essay question. Okay, but I'm going to post another video that will cover other topics you learned about this week, including the rock cycle, types of weathering. I want to get you ready for your test next week. Okay? If you have any questions, you can use Google Classroom. You can comment. Feel free to do that, or you can email me as well. I'm here to help you, and I hope everything is going well and you guys aren't too bored. I'm getting pretty bored here myself. So let me know what I can do for you, and hopefully this helped.